Hai, Assalamualaikum. My name is Nazira binti Mustafa Kamal, my matric number is A10009. So today I will present for off-grid photovoltaic system for residential house belong to Mr. Ahmad Nisfu. I am from group 6, presenting my group members is Afira binti Azhar, Nur Amira binti Saimi, Nur Sufa binti Masain, and Eli Ardila binti Masudi. Next is introduction. Solar energy is a renewable source of energy. In recent years, there has been increased demand for solar electric power system in order to foster sustainable energy technologies. So, as we know, photovoltaic solar energy is a renewable source of energy that can convert light from the sun in order to produce electricity. There are three classes of photovoltaic power generation system, which are grid connected system, standalone system, and on-off-grid integrated system. Thus, in this project, we use off-grid solar photovoltaic system for Mr. Ahmad Nisfu's house. Off-grid solar PV system is the lowest cost possible that can be obtained in rural areas. So basically, using off-grid solar PV is an effective way to use because in isolated areas, due to lack of resources, it is necessary to optimize off-grid solar photovoltaic system as it can minimize the cost. And lastly, it consists of solar panel, charger, controller, batteries, and power inverter. Solar panel contains cells that will convert sunlight to electricity. So inside the cell, there are layers of semiconducting materials that will create electric field to flow when the light is touched with the cell. Then the charge controller will be used to regulate the voltage and current coming from solar panel to the battery to make sure that the battery is not overcharging. The energy that has been stored in the battery will be used during night or cloudy or the time that there is no solar energy available. Lastly, power inverter will be used to convert DC power that have been produced by solar panel into AC power before it's sent to house to use.
Hi, Assalamualaikum. My name is Nur Amira binti Saimi. This chemistry number is AE190047. Now I will be presenting the problem statement for our group project. The fact that the majority of the country's electricity originate from the non-renewable resources, which produce high carbon poisoning in the environment and contribute to global warming, is a major difficulty for the country in dealing with power failure. This is destructive towards the local community and the environment as a whole. As a result, there is a greater demand for the development of renewable energy sources that are less harmful to the environment. The introduction of renewable energy sources uses off-grid photovoltaic system, one of them that are not detrimental to the environment and can also offer free energy, is one of the possible alternatives. Next, I will show you the objective of this project. There are several objectives that we would like to achieve on this project, which are: first, the objective of this project is to construct an off-grid PV solar system capable of fulfilling 100% of the required electricity consumption, which will be installed at Mr. Ahmad Nisfu residential house. Next, the goal of this project is to reduce energy consumption from non-renewable energy sources such as the grid, as well as carbon dioxide emission, by generating electricity using an alternative energy source known as a photovoltaic system. Furthermore, our objective is to optimize the most appropriate design in order to acquire all available solar energy in order to meet the energy demand at a cost that is affordable. And not only that, the objective of this project proposal is demonstrating photovoltaic potential to generate electricity in a clean, environmental, beneficial, and sustainable way. Also include a complete description of solar PV system parts and components and operation principle which will be installed at the residential house that belongs to Mr. Ahmad Nisfu. And last but not least, our project goals is to indicate the off-grid solar PV system design criteria which can be subdivided into several stages, each of which can be properly tested by using PVC software before we install it. Thank you.
Hello, Assalamualaikum. My name is Afira binti Azhar and my chemistry number is AE190067. So I am charged to present the manual design for Mr. Ahmad Nisfu house PV solar panel. So the first step is we need to know how much the total power consumption for Mr. Ahmad Nisfu house. So by including all the appliances at Mr. Ahmad Nisfu house, we can get the total power consumption per day is 13.028 kilowatt hour. Next, the second step is we need to know what is the perfect sizing of solar PV panel. So here is the PV panel specs that we want to put in the PV solar panel. So as we know, the average sun peak hours in Malaysia is 4 until 6 hours. So in this case, we considered for the minimum sun peak hours which is 4 hours. Therefore, by that we can know the PV power where the PV power is 4234.1 watt. And from that, to get the number of PV panel, we just divide the PV power divide by the power rated of the PV panel, and we can get the 94 panels for this based on the PV power. So the third step is we need to know what is the sizing of the battery bank. So this is the battery spec that we use. And first thing first, we need to know how much the battery AH required. So in this case, the battery AH required is 1357.08 amp hour. So by using the battery AH required, we can get parallel and series battery. We sum up that both value, and the amount of battery needed are 6,780 active batteries. So the fourth step is we need to know the sizing of inverter. So to get the perfect inverter power, we need to know what is the minimum inverter power from this appliance. So after the calculation, the minimum inverter power is 3,676.5 watt. And from here, we know that the suitable power rated is 4 kilowatt for the PV solar inverter. And last but not least, for the sizing of solar charge controller, so that here is the spec of the SCC, which by Vmax is 48 volt and ICC is 110 ampere. So the number of series we can get from the VOC from PV divided by Vmax, and we get one series. And for parallel connection, we just divide the total PV panel that we use in the system and divide by number of series, which is 1, and we get 94 parallel connections. So I think that's all from me. Thank you very much.
Hi and Assalamualaikum. My name is Eli Adida binti Nasaruddin. My matrix number AE190074. Okay, so I'll be explaining for the project simulation. So our project simulation name is PVC's Ahmad Nisfu House, that location in the Kampung Parit Lutong, Batu Pahat, Johor. Okay, so I will explain for the main parameter, which is orientation, user need, system detail loss, and for the optional is horizon and near shading. Okay, so I will show you the orientation for this project that have been set up. Okay, so for the field parameter, we use plan B is 25, and for the azimuth we use 0.0. So basically this is the diagram. Alright, okay, so okay, we move to the user needs. So for this project, our group has decided to use this appliance, which is lamp, LED lamps, ceiling fans, television, which is 42-inch LED, and then fridge, washing machine, and phone charger. So this is the total number of this appliance, and this is the power for each appliance that we need to set up. And then this is the daily use that also we need to set up in this simulation, and the hourly distribution. Okay, so we move to the hourly distribution. So for the lamp we use 12 hour, and for the ceiling fan is 14 hour, and for the television is 7 hour, and for the fridge is 24 hour, and for the washing machine is 1 hour, and for the phone charger is 3 hour. Okay, so basically this is daily global consumption. Alright, okay, next after we set up all the consumption, we can move to the next part, which is the system. Okay, so for the system, we got the enter accepted PLOL is 5, and the enter request autonomy is 4 days. And for the battery user voltage, the simulation auto set up for 48 voltage. And for the suggested capacity by the simulation is 1277 AH. And for the suggested PV power is 4391 WB. Okay, so first we look at the storage. So for the storage, which is the battery set, we use battery type, which is lithium ion, and for the we use 3.2 volt 3.1 AH lithium ion. This is type of battery selected, is a cell. Okay, and then we use 15 cells in series for the battery, and 412 cells in parallel. Okay, so basically in the simulation we just need to verify this column with this column. So we use a battery pack voltage 48, same in the upper. Okay, next for the system, after we complete the storage, we need to complete the PV array. Okay, so the PV array, we use 45 WP and 15 volt, which is SI mono, and then we use MPPT converter. So basically, I just set up. Okay, and for the PV array design, mode in series is 1, and for the MB string is 97. Okay. Alright. Okay, so for the detail loss, basically this have no discussion. Okay, so we move to the near shading. So for the near shading, we can see the construction or perspective of our PVCs. So this is our PV field, which is we use four panels, and the active area is 26.61 meter square, and for the total number of module is 96. Okay, so after we complete all the main parameters and the optional, we can simulate the simulation. So we just need to run the simulation. Okay, so basically this is the as a result summary for the daily input or output diagram. This is, and for the performance ratio, PR and solar fraction SF, and for the array power distribution and array temperature versus effective irradiation. Okay, so we move to the report. Okay, so this is the report for our project. So here we got the, as a summary, array losses. For the general parameter, for the PV array characteristic, for the array losses, ISO shading diagram. So detailed user needs, which is the appliance that we use, and the Howley distribution, and also the main result that my friend will explaining in the discussion. Alright, so basically this is a part of simulation, and the simulation made is from manual calculation first. So the simulation will show the result. So I think that's all from me. Thank you.
Hi, Assalamualaikum. My name is Nur Naswa binti Masaid. My guide metric number is AE10054. So right now, I would like to present the discussion for our project. Firstly, in terms of sizing of solar panel, for the PV module in off-grid PV system, we choose the monocrystalline 45 watt due to a few reasons in terms of performance and high efficiency. Monocrystalline is a uniform cell with high efficiencies up to 20%. Other than that, monocrystalline is the oldest and most reliable type of solar cell and have been known to last for up 50 years. However, the cost of mono is more expensive. In order to size the solar PV panel, in the calculation, we estimate the off-grid PV system power of the PV in minimum peak hours between 11 AM to 3 PM is 4,234.1 watt. This estimation PV power approach the PV power that we get from the simulation, which is 4,000 watt. This difference will result in the number of needed PV module. So the off-grid PV system power depends on the energy loss in the system. It will be affected by the efficiency of the PV panel that we use to residential house of Encik Ahmad Nisfu. If more PV module are used, the power in the off-grid will increase. But in terms of costing, 94 PV module was the better choice in order to decrease the cost because we use monocrystalline PV cell. Next, in terms of battery bank. The type of battery used in the off-grid PV system is lithium-ion because it is high efficiency between 92% to 98%. It also is compact size, lightweight, and scalability. The size of battery bank is very important in order to design the off-grid because it can store the energy obtained from the PV panel during the day for use at night or when the weather is cloudy. It is very important to reduce the cost of electricity bill. So we can conclude that in order to increase the battery capacity, we need to use more of the battery in off-grid PV system. So the energy that can be stored also increase, and also Encik Ahmad Nisfu can use in order to apply in the appliance in his house. Next, in terms of sizing of inverter or we can call a solar inverter that is used in off-grid PV system is a power electronic device that can convert DC to AC. Most household load in Encik Ahmad Nisfu house require AC power, but the electricity that is generated by the solar system is naturally in DC. This conversion takes place in real time with a very minimal time gap. The input rating of the inverter should never be lower than the total watt of appliance. So in this case, the total power of the appliance used in the house is 1296 watt. So input power rating of the inverter used in the off-grid PV system is 4000 watt. And the minimum inverter power is 3564.5 watt. The inverter must have the same nominal voltage as our battery, which is 48 volt. So the specification of the inverter that we choose was achieved. Next, in terms of sizing of solar charge controller SCCC, the solar charge controller determines how much current should be injected into the battery for its most optimum performance, as it determines the efficiency of the entire solar system as well as the operating life of the battery. It is a critical component. The charge controller will protect the battery bank from overcharging. Most controllers commonly used are either 60, 80 and 96 amperes, so we need to pick the controller with the next higher rating. So from this case, it would be the 110 ampere controller. It is because we need to consider 20% of the margin and do not exceed the input voltage the controller can take. The manufacturer will dominate the input voltage that should be included in the design. Other than that, temperature and open circuit voltage have to be considered in order to choose the correct size of SCCC. Since PV open circuit voltage VOC goes higher as temperature drop, we need to make sure the controller's input voltage ratings can handle this in the code of winter. So in the conclusion of our project, an off-grid PV system can be useful in a variety of settings and application, especially in our house. By using off-grid PV system in our house, we do not consume any water, emit no pollution, and have no monthly electrical bills to pay. However, the final system is quite expensive and initially investment are high. But it is a good investment because it is still impractical when grid connection is available. So it depends on you whether you want to pay the electrical bills or you want to save the electrical bills for your household appliance. So that's all from our group. Thank you.